Okay, thank you for this great opportunity. My name is Nagisa Sone. Nice to meet you. Today, I will talk about the activities and the future plan for UNISON Satellite Working Group. And I'm Nagisa Sone from Nihon University in Japan. So the title is about the Unison Satellite Working Group, but since the activities of Satellite Working Group have just restarted from this year now, so today I will basically introduce my own satellite activities as an introduction to satellite development by Japanese university students, and finally talk about the activities of the Satellite Working Group. So first, this is my self-introduction. I'm Nagisa Sone, and I'm studying aerospace engineering at Nihon University, Yamazaki Laboratory, and I'm a second-year master course student. And sorry. And I have three main activities. The first one is the wide 6-size CubeSat Prelude project. I'm responsible for project management, communication subsystem, and attitude control subsystem. And second one is the HeptaSat educational training. We develop an educational kit and a textbook like this, called HeptaSat, and use them to teach students around the world about space engineering. And the third one is the UNISON Satellite Working Group. And today's my presentation topic is four topic. The first one is my laboratory's satellite prelude project introduction. The second one is the space engineering educational project HeptaSat training. The third one is the mission ideas for the next HeptaSat model that called Otenki Sat. The Otenki means the weather in Japanese. And the first topic is the Unison Satellite Working Group activity. And first from this slide, I will talk about my laboratory satellite prelude project introduction. This is the prelude satellite, and this satellite is developed in Yamazaki Laboratory in Nihon University. It is mainly developed by the M2 student, the 3 people, and the M1, the first year master course student, the 6 people, and the bachelor 4 student, the 2 people. Totally the 10 student this is developed by 10 students. And Prelude will be launched between financial year 2025 by JAXA's project. The main mission is observation of seismic activity related with ionospheric perturbations for earthquake prediction. Now, this is the Prelude's overview, and the upper figure shows the launch state. The lower figure shows the after deployment. The Prelude is deploy the 2 solar cell panel and extend the 2 mission boom. Each boom is 1.5 meter, and the tip of the boom are installed the electric field and the plasma hybrid sensor of each side. And the satellite mass is about 8 kilogram, and altitude is about 540 kilometer. And this is the Prelude bus unit. The left figure shows the main structure. The 2 mainframe is supported by the C and E-shaped frame and shielding plate. And left figure shows the main bus unit, some electric board, And we will use the codes, some codes, the S-band transceiver from IQ Spacecom. It's the Japanese company. And also attitude determination control unit by Cube ADCS from South Africa. And from this slide, I will talk about the design development process by student. For electric boards, the student, the student do board design with eCAD from such as this figure. And after the design, the manufactured at company. And for structure, the student create drawing like this figure and manufacture them at the company. And we also do some analysis like the power and the attitude and the thermal condition by MATLAB, and also done using the combination of homemade code, Excel, some program, and purchased software like this. And we will also we made the 3D printer mockup and check assembly and the evaluation some evaluation the satellite evaluation satellite in clean room. And we also do environmental testing like the vibration tests and shock test like this. And this is the overview of the Prelude satellite project. Now from this slide, I will talk about the HeptaSat training. The HeptaSat training is practical hands-on learning of the CubeSat system, which is widely used in universities and companies around the world to learn the basics of space system design through actual products. And HeptaSat is a 1U CubeSat education kit, like this figure, like this left figure, that contains a satellite bus system, including a microcomputer, battery, transceiver, sensor devices, and structure. By using the kit corresponding to the textbook, anyone can understand satellite system in a short time, and easy access to space for newcomers. It's because they're requiring only an internet environment and a laptop computer. And this is the HeptaSat Lite. This is a new training kit that simplifies HeptaSat into a single chip, only 55mm palm-sized board. In this board, the OBC and the regulator and switch and 9-axis sensor and temperature sensor is included. And easier to use because of its very small and low cost. And most sensors and other functions are already included on a single board, one board, so making it easy to use for other applications like CANSAT or a rover or something. And I will talk about the HeptaSat training effects on assistant student. The HeptaSat training is a good opportunity for the participants and also for the students. The students who are developing satellite at my Yamazaki laboratory participate in HeptaSat training workshop as teaching assistant. So students can experience international activity and can feel closer to the world and grow to skill of engineering communication. And also the improving textbook and kits by using what students learn from satellite development. And from this slide, I will talk about the third topic, the new heptasat training vision, the OTENKISAT. And we are currently looking to create new heptasat training that integrates engineering and science, add learning experiences in satellite operation and data analysis. This is the overview of OTENKISAT we are planning now. And first, the base is the heptasatellite and add a weather sensor. And second, the satellite observe weather outside for long term. And after that, estimate satellite condition from the data analysis. And advantage of working with weather data, this is two merits of using weather data. The first one is easy to evaluate data. Temperature, humidity is easy to understand and can handle without any specialized background. And many reference data are available, making it easy to confirm the accuracy of the data. And second merit is the data analysis experience of natural phenomena. The natural phenomena caused unpredictable fluctuations and sudden events, developed the ability to understand complex data in the process of analyzing them. And why do I want to create new heptasat training and the challenge of heptasat training? Now heptasat training lacks experience in the operational phase, especially in the use of analysis of data from a scientific perspective. So I want to add, in addition to an engineering approach, an understanding of the scientific theory of data is essential to the use of data. Like this, the engineering is the design, operation, and technical realization of the mission, like develop hardware, software, system design, and so on. And I want to add science perspective, like mission design and data demand and data analysis. So I want to design educational programs that cross the disciplines of science and engineering. The in This is a vision of hardware configuration. The base is the heptasatellite and add some weather sensor like temperature, humidity, air pressure, and so on. But this is the under construction. From this slide, I will talk about the fourth topic, the UNISON Satellite Working Group. The UNISON Satellite Working Group is composed of students doing satellite-related research. And UNISON Satellite Group's purpose is to solve problems that cannot be done in the one laboratory and share issues that have come to light through the development of satellite. This is the picture of UNISON Satellite Group. And we have two main activities. The first one is a regular meeting to report on recent activities. This is held once every 2 months. A regular meeting attended by students belonging to UNISON Satellite Working Group. In this regular meeting, provide a platform for exchange of ideas and knowledge among students involved in satellite development. And we will share the efforts and the issues of each university and solve them together. like having trouble with satellite development and want to cooperate with other universities. And I want some student want to develop a satellite, but they don't know where to start. And the second activity is a UNISON training program for new student. This is the plan to be held in this year, 2025. It will be hold a training for new students in laboratories that are developing satellite. Maybe 2 days training course. Like this, each university have new student and they join the Unison Satellite Group training program. And in this program, they share and teach how to develop satellite engineering knowledge and share the lessons learned from each university. And also maybe the visit each laboratories, the laboratory tours, maybe. And to provide an opportunity for the new student to interact with other students, to make connections, and to give motivation. We will plan to this. And the future plan satellite working group. Since the satellite working group was inactive last year, so we have restarted its activities from this year. So we will start with the two main activities I mentioned before slide. And we have other opinions are raised as follows, like this. And we will work on them one by one, step by step. So to improve the basic level of satellite development in Japan through student activities. We would like to be a satellite working group to achieve this. So this is conclusion. So thank you for listening. That's all.